Welcome class. Welcome to Programming Logic and Design with Python. So I currently have the Blackboard page open. I just wanted to kind of show you guys around so you guys are familiar with what is important to look at. So right now I'm on the announcement tab. It's going to look a little bit different for you guys. I could actually change that. So this is how it's going to look for you guys. So the most current announcement was posted 20th. If you guys just read it, it's basically saying to go over the syllabus, take a look at the new section I added for homework, that the first day was yesterday, and that the week 1 assignment is under course content. So if you guys could just look at that announcement. There's a previous announcement as well, kind of saying the same thing. It was posted a while back. You guys could read that too. So under course content, where we have at the moment just the syllabus and resource policies and procedures that Tunksys requires us professors to make available to you guys. So you guys could just read through that. Under course content, so this is where I'm going to put weekly assignments, PowerPoints, these video recordings, and anything else, really. So right now there's just week 1. So if you click week 1 folder, you're going to see the PowerPoint presentation, which is what we're going to go over during this recording. You're going to see chapter readings, which is the actual textbook readings that I assign each week, and you're going to see homework assignments. And so under homework assignments, you see that there's 4. We're kind of going to go over them during this recording as well, just so you guys are a little bit familiar with the baseline syntax of Python, just so it's not too overwhelming. So we're going to go over that during this recording. The chapter readings is basically section 1, 2, 3, and 4. They're not too long. I recommend you guys read it so you guys have more of like a fuller understanding of Python past just the PowerPoints, past just us reviewing the homework assignments. And obviously the PowerPoint we're going to go over now. So that's Blackboard. So we have the syllabus here. I figured we could go over it together, just really quick. So here we have the title of the class. We have my contact info. So if you guys have any questions, whether it's homework related, test related, just general questions, I don't understand a certain concept in a chapter, then just shoot me an email and I'll respond as soon as I can. I'd say 24 hours. I'd probably try to get back to you guys with something. So office hours, I don't have official office hours, so you guys would just have to reach out, and I wouldn't mind meeting via WebEx or via in person at Tunksys if they allow me. I know with the whole COVID thing. So just reach out. We could schedule an appointment, whether it's virtual or in person. If the question can't be answered via email. So try email first. Then we have course description, we have student learning outcomes, just general stuff. The textbook, so this is the textbook. It's MindTap for Cengage Python Fundamentals, first edition. The ISBN is right here. So I know I had one student reach out saying that they had a question about whether they should just get the access code or they should get the textbook. Like, do you need both? I recommend both, because the access code doesn't necessarily give you access to the textbook, and the textbook isn't enough because we use MindTap, which is like Cengage's in like own environment for us to do our lab assignments, which are, the lab assignments are our weekly homework stuff. So you kind of need both. I know Tunksys offers, if you go to, let me go back to the Blackboard tab. Um, I believe if I do course search, it should bring up the textbook. So you would just go under spring term 2022, go for Tunxus. And if you guys need this link, I could just send me an email and I can forward it to you. Find in page, we're going to find myself. And so you just do textbook info, and Tunxus offers it like the full textbook and access code right here. That's the price. It's a digital book, so keep that in mind. So yeah, that's the textbook. Go back to the syllabus. So the grading scale. So I put a lot of importance on the homework because I feel like that's really the best way we're going to learn Python. The tests are also important, but um, there's more weight on the homework. So if you guys get the homework in, it's going to be easier for you to be successful in the course. Obviously, we do have 3 tests. Um, we'll go over the weekly schedule a little bit later on in the syllabus, but just know that there are 3 tests. We have the evaluation or the grading scale. This is just Tunxus's default grading scale. Academic integrity. Just do your own work. Try not to don't copy. Not try. Don't copy. Um, and I kind of like I put some stipulations on like if I find homework that is too similar to someone else's, what the repercussions would be. Um, but you won't have to worry if you just do your own work. I'm here to help, so just shoot me an email if you have a question. Attendance and makeup. It's an online course. So attendance is kind of just logging into Blackboard every week, making sure you get your work done, and just submitting it in a timely manner. Makeup, you guys could read that section. So here's the course schedule. So we have week 1, Introduction to Python, which is chapter 1. So the assignment would be read chapter 1, and then we have lab activities, which is your homework, which the first week, as you can see here under the homework schedule, is due on January 29. So you guys have 7 days from now to do it. And also, we're going to kind of go over it today in this video, so if you guys don't really know how to approach it, I'm going to kind of give you my approach on how I would approach the problems, and you guys can go from there. And yeah, so I think that's it for the syllabus. We are going to go into the PowerPoint. So PowerPoint right here. Okay. It's kind of a long PowerPoint. It's 44 slides. I just kind of went over the textbook and picked and chose what I thought was the most important aspects of the chapter. It's kind of how I'm going to go about every chapter that we cover. So introducing Python, or introduction to Python. So what is Python? So it's a high-level, general-purpose programming language. Uses pseudocode-like syntax that places emphasis on readability and expressiveness. It's kind of like, it depends on if you guys have taken any other programming languages in the past. Python is more straightforward. That's what it kind of means like when it says pseudocode. So features vast standard library and even larger array of third-party libraries. This meaning like you don't have to really call certain libraries when you're running a piece of code because its standard library is so big. But you can call additional libraries as needed, which we'll see in the homework assignment, and one of the homework assignments. So it's also an interpreted language, meaning instructions are interpreted at runtime without a need for precompiling the program into a machine language, which is the case with C++. So that kind of just means that it doesn't it doesn't really like so usually coding language has its own syntax, and then when the machine runs it, it changes it into machine language. In Python, it doesn't require that to. That's not really the case. It just it'll be interpreted as the program's running, which is why it says no pre-compiling of the program. It sounds a little bit confusing, but I'll kind of explain it as we go. So what OSs support Python? So Python's versatile in its ability to run on a lot of OSs, all OSs really. So you got Windows, you got Mac, you got a bunch of Linux distributions. It runs on all of them. Python is preloaded on Linux and Mac OS, but it's not on Windows. You have to install it. So, and that can be done through the command line prompt. I think there's a mini lab that that shows you how to do that. That wasn't assigned for homework. So if you guys want to just do that or do that mini lab on your own, you're not forced to. In case you want to run Python on your own actual computer, you can do that. So applications for Python. So what are the uses for Python? It could be used for writing automation scripts, machine learning, scientific computation, big data, web applications, GUI programming, IoT devices, and here's a list of companies that use Python in their own business, like Google, Uber, Facebook, and Mozilla. So Python environment. So for this class, the MindTap environment is Windows based. We're not actually going to be running Python in anything that's not Windows. So that's why I said we'll be using Python in a Windows environment. And for the most part, Python is generally used in Windows environments by most Python developers. And we just have like a stat to back that up. So, by the way, this entire PowerPoint is, like I said, it's on Blackboard. I say that because there's links here in case you want to download it for yourself. So, installing Python on Windows 10. So, it does not come pre-installed on Windows. The latest version of Python could be installed by clicking on this link. And then I also put a walkthrough on how to, like the syntax you would do in command prompt to successfully run or install Python and any dependencies that are required. And you would just click on this link, and it's a very simple walkthrough. So the Python interactive shell. So this is really just a command prompt, but within the command prompt we can call the Python interactive shell once Python's installed on your computer, and you really just do that by typing Python. And then your latest version of Python will show up, and as you can see in this little, it says Python 3.9.9, and then so in order to access Python in the command shell, type Python, hit enter. It will look similar to this as long as Python is already installed. And you'll also notice that you're in the Python interactive shell because you're going to see these three little arrows pointing to the right, and that means you're within it, compared to the regular command prompt, which shows you the directory that you're in. So my directory was c:\users J Gonzalez. So you can see the difference there. Benefits of Python interactive shell. So the Python interactive shell interfaces with the Python interpreter, allows us as users to execute Python commands directly in the interactive shell. So like these three lines, these three arrows, at that point you could just start typing in Python syntax, and as long as it's correct and not too complex, it'll return the result of whatever you syntax that you guys write. And we'll see that later on. So that's what it means with it allows you to execute commands within the interactive shell. It should be noted that when you exit the Python interactive shell and relaunch it, any variables that were defined or commands that were run in the previous session will no longer exist in the new instance. So just keep that in mind. And then if you want to say you have this really complicated script and it's too difficult to run in the interactive shell, you can actually save it as a text document, change the file, the end of the file so that it's a .py file format, a file extension. Change the file extension to .py, and it'll save itself as a Python um, executable file that you could run within the Windows command prompt. Not necessarily within, well, you could run it in both. You would just have to call the entire path, which I'll show you a little bit later. So limitations of interactive shell. It cannot run full-fledged programs through the shell, which is why you would save it as a .py file for bigger programs. However, you can run them through a saved file. A file containing Python instructions is called a module. A script is a module that can be run. As mentioned, Python scripts should have the file extension of .py. In order to run a .py file in the command prompt window, obviously you have to locate the directory in which the .py file exists. So right here I have an image of a test1.py file that I created on my own computer. And in order for me to run this in the command prompt, not the Python interpreter, just the regular command prompt that has :C users jgonzal or jgons. So within that directory, I would type C colon backslash users backslash jgons backslash desktop. Well, first I would type Python space, then that entire path backslash test1.py in order to run that specific program from my own desktop. Now, in the Cengage MindTap environment, you don't have to do that. It kind of just it takes that out because and it simplifies the environment by not requiring you to know the path of your specific file. But in a real world scenario, you do need to know the path. So the next slide, writing/running a script. So in order to run the .py file, you must change directions in the command prompt window. So I kind of showed it right here. So originally I'm in the colon or C colon backslash users backslash gons. I actually changed my directory here to where the Python script exists. So I did cd, which allows me to change directory, and then I stated the directory that I want to move up to, and that being the backslash desktop. And then from there, you could just run Python space test1.py and it'll return the result. So this is just kind of proof and how you would do it in case you want to do it yourself. Now, could I have just moved my Python script into the users backslash jgons folder? Yeah, I could have done that too. It would have saved me the trouble of having to move directories within the command prompt. But it's up to you on where you want to save your Python files. But just kind of want to point that out because it's kind of important. So this kind of just explains what I just said. Oh, actually, so the reason it said hello 5 times was because my script told it to say hello 5 times. But we're gonna see the content of my script is actually right here. So the following was written in the notepad and saved as a .py file. So this script syntax was what was in test1.py. So it's print open parentheses, quotations, a bunch of dashes, and then the next line was print quotation hello space close quotation times 5. So the times 5 is basically just saying say hello 5 times, or print out hello 5 times. And then after that, it's going to print a bunch of dashes, which we see right here. So yeah. Invalid commands. Putting invalid instructions in a Python script will return a traceback. I believe I have a screenshot of traceback, which is an error message that tells the user where an error occurred, what kind of error occurred, and what other calls were triggered along the way when we ran the command. Traceback error should be read from bottom to top. So right here. Oh, actually, this is kind of important because this is actually going to go into lab 1 of the homework assignment. So passing user arguments to scripts. Taking the same test1.py script used earlier, I've deleted the entire script that was within it and replaced it with what we see in the screenshot: import sys, enter, print. This argument was passed to the script in quotations, comma, and then I put sys.rgv, and then 1. We're going to see what this means. What this actually does is it allows the user who's running the script to add anything they want to the end of this print string that we have right here. And we're going to see that in one of the homework assignments as well. It's a more dynamic way of running a script, allowing the user to kind of enter in data that may pertain to the string that we're printing out. So if we go to import the next slide, import syslab 1.2. Did I miss 1.1? I did miss 1. We're going to go back to 1.1 before we get to that. So let's open lab 1.1. Close this. Okay. So lab 1.1, it disconnected me. Okay. I might have to close out of this. Close this. Okay. So this is what's going to show for you when you open up the lab. It's just going to open up a terminal on your right side, and then it has instructions on what it wants you to do on the left side. It's kind of the same format for everything. We're going to see on the right side, they're going to give you a notepad in addition to the terminal for later labs, but right now it's just the terminal. So this is lab activity 1.1. It wants you to use the print function to print Happy Earth Day to the console. So the way to approach this is, we haven't really gone over syntax yet, but we have seen the print function be used, which is basically just typing in print, then open parentheses. And if we want to print out a string, we would use a single quotation. That's not necessarily true. You could use a single quotation or a double quotation. Double's really reserved for strings, and then a single could be used to print out, say, like a number. They both work. It's really up to the programmer, but traditionally the double quotation is for strings only. So because we're going to print out a string, we'll use double. So print happy. I just realized I need to get into Python. So yeah, make sure you get into the Python interpreter before you do that, because we're still in the regular command prompt window. And now we can do it. Do print happy, let's uppercase that. Happy Earth Day. And then we'll close it. Print. There. So within the Python interpreter, it returned our Python request. So it printed Happy Earth Day. And when you're doing this lab, after you do anything, just to make sure that it's done correctly, you can click on these boxes down here where it says tasks. And so like I'll click the first one using print function print Happy Earth Day. And it'll tell me if the result that I got, so it doesn't like it. Hold on. What could be the problem is the parentheses. So let's do single parenthesis. We'll check again. Uh-huh. We'll finish all of them first, and then we'll do it. That's what it might be asking for. So that's one. Let's do the second one. So the second one is basically just asking us to do some basic arithmetic in the Python console. So 24 times 6, or 24 plus 6 times 3, 42. So when we do enter in calculations such as this in the Python interpreter, it does follow PEMDAS. So it's going to do 6 times 3 before it does plus 24, which is why we get 42. Instead of 24 plus 6, 30 times 3, which like 90. So Python does understand PEMDAS. And then the final one is print. So we'll do print 0, 1, 2, 3, 4, 5, 6. Because the reason we do this is it wants us to print this series of numbers in one row. It doesn't want us to necessarily assign it to a variable yet, which we're going to see a little bit later on, where you assign values to variables. It just wants us to print those numbers. So that's why we just did that. Let's see if it marks it as correct yet. Make sure to run the statement to the console. I don't know why it doesn't like my code. I'm gonna try a different terminal. Give me a second. Python, do print. Birthday, 24 plus 6 times 3. And we'll do print 0, 1, 2, 3, 4, 5, 6, close. And now we'll check. Haha. Perhaps this is like bugged or something, because these are right. We'll close that. We're going to open it again. You know what though? It might actually want me to run it all at once. That could be the thing. If you need to type IPython. An enhanced interactive Python, okay. So perhaps it wants us to run it in here. Print. So this would just be the same as typing Python and getting into the Python interactive shell. This just says enhance interactive shell. Perhaps this is just where it wants us to do this specific lab. We'll see in a second. Okay, we'll check. Okay, it does take it. Okay, so for the homework one, even if you do write the correct syntax, it does want you to do it within the enhanced interactive Python shell, so just make sure you do that. Um, but obviously, if you have questions, if you didn't see this video, you might not know that, so just reach out to me via email. So that is lab one. I believe we'll go back to the PowerPoint. Let me get the PowerPoint up, close this. We were just about to do lab 2 actually. So we changed our script here. The import sys imports the sys module that is built into Python into our script. So this is a library that exists outside of Python's default library, so we do have to call the sys library by typing in import sys at the very beginning of our script, which we'll see in the lab. So this module provides access to Python interpreter functions. It is used here to read command line arguments that have been passed to the interpreter when invoking the script. When we call sys.rgv bracket 1 close bracket, we are asking for the first argument that's been passed when running the script, so you'll see in the lab, but it basically takes, after we write a script, after we print out a string, technically, or usually at the end of that string, we include the sys.rgv bracket 1 or 2 or whatever. So this is asking the user, whatever the user types in first is what's going to replace this. And say if there was a 2 here, whatever the user typed in second would be placed in this placeholder. But we'll see in the lab. So to pass an argument with spaces, enclose it in quotes, I'll also show you that. So we're going to open up MindTap one more time. And go to 1. What lab was this? 1.2. So start assignment. Wait for it to open. Usually it doesn't take too long. So yeah, this is what I meant. So it's going to give you a terminal on the far right side. In the middle, it's going to be a text document, which it already saved it as a .py, but it's really just a text document. And then on the left side, instructions for the lab. So it already has my code in here, so I'm just gonna delete this. Okay. So the instructions bit, you won't have this actually. So the instructions say it wants you to create a Python script that executes from the command line. It should take the initials and nickname of a name as arguments and give the output as shown in figure 1.6. So this is the final result that you should have. Not necessarily the Mr. and the Matt. That's a user, that's where the sys.rgv, whatever the user types in will appear as that. So you could type in whatever you want there. But we'll start building the script now. So it says go to main.py file and import the sys built-in Python module. So basically it's just asking you to type in import because it wants you to import the sys module, and then you just do sys, sys, and that imports the external library into your script, into that specific script. That way you can call certain functions within that module within your script. Else Python won't know what that specific function is or what it does. In our case, the RGV function. So the next set of instructions says use two print statements to print initials and nickname. So also use these print statements to print 20 dashes as borders above and below the initials and nickname. Okay, so my approach would be we need 4 print statements here. So we could just type in print, 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 print. It wants 1 print statement for initials, 1 for nickname, and then 2 separate ones for just dashes. So the first print has to be the dashes because it wants the 20 dashes as borders above and below the initials. The initials and nickname. So initials and nickname are going to go in the middle. So we could actually write that one first. So as any other print statement, you do print, open parenthesis. If we're typing in a string, we want to do the double quotations, and then we do initials. And then we're going to do colon, because we want to follow the format that we see right here, where it says initials, colon, and then we have a space. So we have to actually include the space in our string. So we do initials, colon, and then just make sure you do a space between the colon and the closing parentheses, or yeah, parentheses. And then we'll do a comma, because we're not done with that print statement yet. We're going to get back to it. And then we'll do the print, open parenthesis, well, when you press one parenthesis, it writes both of them for you, just so that you don't forget. So that's nice of Python to do. So we'll type in nickname, colon, space. And then don't forget the comma at the end, because that's what's separating the string from whatever else we put. In this case, we're going to put the function, and the function is why we imported sys. I believe they mention it. They mention it in step 3. We won't get to that yet. So we'll finish our print statements first. So print, it wants us to do 20 dashes. So we'll do the parenthesis again. We'll do... So instead of typing in, technically we could type in 20 dashes like this, but that takes a long time. So we're just going to do 1 dash, and then we're going to do times 20. So this is basically telling Python, print this dash, but then do it times 20. So that way we don't have to type out 20. It kind of goes back to the PowerPoint where we... let me close MindTap for just a second. I believe I used it in one of my scripts. Yeah, so the hello. So in a slide we covered, when I ran test 1 initially, I told it to do hello times 5. Now I could have typed 5, but that's just extra work. I could just use this quick syntax to make Python do it for me. And that's what we're doing in the lab. So I'll open MindTap again. So where were we? Okay, yeah. So we did this, and we're just kind of going to copy the code from that first print statement for the last one, because what they want us to do is the same thing. Enclose initials and nickname with 20 dashes on the top and bottom. So that's that. The last thing we want to do is we want... So step 3, 2 parameters should be passed with the script. One for the initials and the second for the nickname. So what they mean by 2 parameters is they want the user to be able to interact with the script and write whatever they want when they run the script from the terminal. So for us to do that, we did the first step of importing sys, but now we have to place the function at the end of our print statement so that the user is allowed to run or pass parameters into each print statement, which is what they want. So we would just use the sys.rgv, the bracket 1. So this is going to represent the first parameter that the user enters. It's going to go after initials. And then the second parameter, I don't know why I did that. Oh. Huh. Okay. I'm going to write this over again. Sys.rgv 2. Okay. So now our script is done. It includes everything they wanted us to do. We imported the sys module. We created 4 print statements. 2 of them are just borders. So we placed one at the very top so that it executes first, and then one at the very end so that it closes our script with that last print statement, which is what they want. Within it, we have initials and nickname. We're printing out that string. And then we're adding the sys.rgv function at the end, allowing our user to add stuff when we run the script. And we'll see when we run the script right now. So to run the script, we're in the regular command prompt window. You could also run it, so like when you're running a Python file, you don't have to necessarily enter into the Python interpreter. You could just run it from the command prompt window, and then just type Python. Here they want us to type Python 3, main.py, and main.py is the name of the Python file, which is the text file saved as a .py. So it could be test1.py, it could be whatever you save it as. In this case, it's just main.py. And now you can't enter in the... So if I press enter right now, it's going to give me a traceback error because the script is looking for user input at the very end. That's why it's not running. So if I took out the sys.rgv from both these middle print statements, it would run, and it would return initials and nickname, but without the ability for the user to enter in any additional input. But in this case, it won't run. So we have to type it again, Python 3 main.py. So initials, my initials are JG, and then space, and now I'm gonna, so JG is gonna be the first argument that's passed, so that's sys.rgv1. So JV will replace that in the output, and I just do space, and then I can do, so my nickname JP, and that's going to be passed as argument 2 under nickname. And I can just press enter, and there we go. So now if I check this, it should work. Great. And then great. Yep, okay, perfect. So, yeah, I believe the PowerPoint said, yeah, so to pass an argument with spaces, we would enclose it in quotes. So I'm going to show you that too. So if I do Python 3 main.py, if we want to, so we do closing in quotes, so quote space JP or JG space, we close the quote, space JP. So now when we see the output, there's a bunch of spaces before JG even starts. So if you were going to write a string, say like, say I want to write Python 3 main.py, I don't have a nickname. So we're writing a string. It allows you to do that, and then JP. So yeah, it's also useful for that if in case you don't want to just write one word, you want to write a string that has spaces, you can do that. So that's lab 2. So let me close MindTap, open up the Python. Um, let's go back through this. Okay, so now when we run the script in the command prompt, we get the following output. We get this. Oh, so this is basically continuing what we just went over about the arguments. Notice how in addition to this typical Python test1.py syntax, the word foobar was added at the end of the command. So the test1.py in this case has the same sys library imported into the script, and it's using the argv bracket 1. And I'm typing in foobar to replace that placeholder in the script. So that's basically what this is just saying. Variables are references to values in memory. Variables in Python can reference values of different data types such as strings, integers, floating point values, booleans, different data types, and data structures. You are not required to pre-declare a variable's data type. This is done during runtime of the script. A variable is used to represent the value inside of it, and a variable's value and type can change during runtime. Any variable can be used to store any data type and can be used as long as it already has been defined. So a variable is, let's go back to the Mind tab. Let me get Mind tab back up. So if I were to define a variable, it would be something like cars. Cars equals, and I could assign a string, I can assign a number, I can assign, I think, what else did it say? Yeah, a string, an integer, which is like a number that doesn't have decimals at the end, floating point, booleans are arguments, and then different data types, data structures, yeah. So right now, we'll learn most of those later on, but right now we're just focused on strings and integers. So if I open this back up, I do cars equals a string. So to define a string, you have to do the parentheses. And I'll just say like Toyota. So if I run my script, actually, I'd have to print it. So print cars. So if I run my script again, it should print that out. Because I created the variable, which is cars, and then assigned it a value of a string, which is Toyota. And then I printed it out so that it's visible to the user who is seeing the output of the script. So here I'll do JG, JP. Yeah, okay, so initials, JG, and we can add to this. So when you're calling a variable, a user could get confused as to why Toyota is here. So we can just be like, well, we'll see later on in the chapter. I believe we go over it. Like conjoining strings with other value or other variables. But basically, a variable is something that you assign a value to. In this case, it's cars. So yeah. Let's close MindTap again. Where were we? Okay, values. Python supports several different types of values. Numeric values in the form of integers can be used in Python interpreter to echo a value or to perform arithmetic operations, as we did in the first lab. You could also check the type of value by typing the syntax type value. So we could do that too. Well, actually, did I include it in the screenshot? No, I didn't. Okay, let me open up MindTap again then. I'm going to erase all of this. Actually, we don't even need to do that. We'll just open up Python, we'll do type, and we will do, what was the syntax of that? We'll do 10. Perfect. So if you see on the bottom right of the screen, it says, when I typed in type, open parenthesis 10, it gives me the result of type int, meaning integer, which is a number. That's not a decimal. So yeah, it basically knows. So if I do type hello, that should return a string. So yeah, that's basically what it means there. So that's values. When checking the type of a value, such as the output of type 10, yeah, I just went over that. String values. A string value is a sequence of characters that are placed in between two quotation marks. So it could be a name, it could be a phrase, like a sentence, like Python is easy. As you can see, we can use double or single quotes for string values. Python will take both. And strings can contain numbers, letters, and symbols. Type conversion, Python allows you to convert string type values to integer type values and vice versa. So I believe this is useful when dealing with user input, since everything is returned as a string value. To convert an integer into a string, use the built-in function str. Okay, so yeah. So I had the integer 10. I placed it within str, open parenthesis, close parenthesis. It changed it to a string, and then it surrounded it with quotations, single quotations. And that's kind of like how it converts it. And you could do it both ways, as you could do int, and then you could place a 10 in there, and then turn it back into an integer. So there's that. To convert from string to integer, use the built-in function int, open parenthesis. Now, if you try to put a string value within that, it'll return an error because you can't convert a sentence into a number. So Python recognizes that as well. So assigning values. To assign a value to a variable, the syntax is simple. As we saw, you have to state a variable and then assign it a corresponding value. So the variable here is number, the value is 7. To print out that variable, to print out the variable's value, you would just do print and then state the variable. Now, when you do print and number, it's not going to print out number. It's going to print out 7. So just keep that in mind. To unassign a value from a variable, you would use the syntax of and then delete. So you would use the syntax of delete number. So like del, what was the variable we defined here? Cars. So if I didn't want Toyota to be binded by car anymore, if I didn't want that variable to value relationship to not exist anymore, I would do del cars, and then Python would erase it from memory, and then you could just reassign cars to whatever other car type you would want. And that kind of brings us into lab 1.3. So we're going to bring up MindTap again. Close this. 1.3a? Yeah, 1.3a. Okay. So, wait for this to load. Takes a bit of time. And, it remembers my code, so I'll have to keep that in mind. Is there not a quicker way to delete this? Oh no. Oh, okay. I deleted the entire file. My fault. We'll just reopen it. Hopefully it gives me another file. Really? What was it called again? Main.py? Create file. Okay. So if by any chance you delete the main.py file, you can create it again, doing the same thing I just did. Um, so this is kind of like a longer, more. They're asking you to convert stuff here, not just assign stuff to variables. So there is a little bit of math in this problem, but I'm going to walk you through it. So at least my approach. So aim. Using variables, write a script that defines a distance of 60 miles in a completion time of 3 hours. So I always go sentence by sentence if it gives me enough information, and I try to start writing the code right there. So for the first one, it says using variables, which we know is anything we assign a value to. Write a script that defines a distance and a completion time, and it gives us values for both of those variables. So the first one will be distance, but it's not just distance, it's a distance of 60 miles. So we'll do distance underscore miles. Python does allow you to do that, using the underscore to represent or to replace what would be a space in regular human sentence structure. So distance underscore miles, and then we're going to assign it 60 because that's what they tell us. And then for the other variable, it wants us to do time. So we'll do time in hours, though. It's not just, it gives us like a specific way of measuring time. So we're going to include that too. And then I believe it's 3. Okay, so that's just the first sentence. They gave us 2 variables, and they gave us 2 values to assign to those variables. And this is what I usually just always do when I'm writing any, whether it's Python, whether it's C++, Java, I always try to break down the problem with sentence by sentence, if you can. The output should show a completion speed in miles per hour, knots, and feet per second. So that's multiple. So it says output. So output usually means like print statements. So we know we have a print statement that should show the completion of speed in miles per hour, and then comma. So that means that's one whole print statement right there. And then we have our second one is in knots, and then a third one in feet per second. So let's go one at a time. So we'll do print, open parenthesis. It wants us to do speed, so the speed in miles per hour. Speed in miles per hour is, because we're going to have a value at the very end. So we're going to do is colon space, because that's usually, you know, it's cleaner, because if we don't include the space, the number is going to be right next to the string, and it's just going to look weird. So we want to do the space. And then close parenthesis, and then don't forget we always have that comma, because we're going to add something at the end, we just don't know what yet. We're just making the print statements. We're just handling the second sentence of this homework assignment. So that's one print statement. The second print statement is going to be the output should show a completion of speed in knots. So the speed in knots is, and then don't forget the comma, and we're going to leave it as is. It's not done yet. We're creating a program bit by bit. Um, Obviously, there's other approaches. This is just mine. So print speed, and so show a completion speed in feet per second. So this is feet per second is colon space and then the comma. Okay, I believe it was just 3. Yeah. Okay. So we're done with this part of the homework assignment. Now we have to move on to, here are some hints. Okay, so we have distance in miles, right? But that's not the value we need for these print statements. We need speed in miles per hour. So we have the time and we have the miles. So now, to calculate speed, the formula for they actually give you the formula. The formula for calculating speed is distance divided by time equals speed. Okay. So uh, the formula. Okay, yeah. To convert miles to knots, divide the miles by the specific number. Okay. So we'll do that first. So we're going to create a whole nother variable, which is going to be distance underscore in underscore knots. And then we'll do enter. And then we're going to take a previous variable, which is distance miles, and then we're going to divide that by 1.15078, because that's the number they give us. Because they say if you want to convert from miles to knots, you have to divide the miles by that specific number. And we already have miles as a predefined variable up here, 60. We could write 60 here, but there's no point in doing that because we already have it assigned to a variable. It's just cleaner that way. So that's one. They want us to convert miles to feet, so let's do that too. So that is distance miles. No. Distance in feet. Because this is the variable. And then distance in feet. And now it's distance miles. Multiply by 5280. Okay. So, and then they also say convert hours to seconds. And we're just creating all these variables. It doesn't necessarily in the instructions say to create them like it does. Well, it infers it more in this first sentence, but here they're basically saying it's helpful to create these variables because we're going to use them later on. So that's why we're doing this. So convert hours to seconds. We already have a variable that gives us hours, or time in hours, but now we have to do it in seconds, so time in seconds. So we're going to create a whole new variable, time in seconds. We're going to use our past variable of time in hours, and as you type it, it already knows it's defined in the script, so you can just click it and it'll fill it in. So like if I did this, yeah. And then it says multiply it by 360, or 3,600. Okay, so we got that so far. I like to separate it. Obviously you can put that here, but because these are stuff that deal with distance, I keep them in their own group. As long as all of this is defined before the print statement, you're fine. But that's just kind of how I do it. I space it out. So now it says, okay, go to your main.py file. Oh, these were okay, these were the instructions, but whatever. I kind of just worked off this. On the first 2 lines, declare 2 variables for the distance in miles and time in hours, which we've done. In the next 2 lines, calculate the distance in knots. Okay. and we use the conversion right here, and distance in feet. Okay, we're good so far. Then calculate the time in seconds based on the time in hours. We're good so far. Okay. Next, calculate the speed in knots, speed in miles per hour, and speed in feet per second. Okay, so those three things are completely new variables. So do speed, speed in knots. What's the speed in knots? Yeah, speed in knots is first. Equals distance in knots. Oh, distance in knots divided by time. No, wait. Speed in knots. I believe it's time in hours. Because they're not asking us specifically for seconds or hours. So I would do hours. Okay. And then we got speed. What was the second one? Speed in miles per hour. Speed in miles per hour. And then this is distance in miles per hour divided by time in hours. That should be good. And then speed in, what was the last one? Speed in feet. Do feet. Now we'll do distance in feet. And so going back to that's why it's good to have these print statements, because I was like, what do I divide this by? So here, the speed in miles per hour would be by hour. You would divide by hour. You divide the distance by hour. For speed in knots, I just kind of assumed it was hours. But for speed in feet per second, which is what they asked for up here, that means we actually have to divide this not by time underscore hours, but by time underscore in seconds, which is why they had us do this. So that makes sense. So now we have all of our variables defined, we have values that are using past variables. So now at the very end, we're going to place these last variables, speed in knots, speed in mph, and speed in feet. We're going to place those here, because these are the final calculations of everything else prior. So for speed in miles, we're going to do speed. So yeah, this is super simple to click in now that we have everything done. Speed in knots, and then speed in feet right here. Okay, that's it. That should be it. In your terminal, yeah, so finally add print statements. See, that's why it's good to add the print statements beforehand, or else you wouldn't know what to divide the distance of each of these things by. Well, you could if you look back in the instructions, but it's already in your script, so you don't have to look far for what you're supposed to write there. So yeah, now we just have to run the script. So it actually gives you the syntax of what you need to type in. So Python 3 main.py, and there you go. It should look, unless your print statements are out of order like mine are, and then obviously you can check with the task here to make sure everything's good. It says it's good, great. And that's lab 3. It's a little bit harder than the other ones, but if you just take it step by step, the steps for completion are actually pretty good, but it's not always going to give you these. A lot of times it's just going to give you this part, stuff I'm highlighting. So just break it down by sentence, just like how I did it, and you should be fine. So yeah, that's lab 3. So let's go to close Mind Tap. Back to the PowerPoint. I don't want to make this video too long. I know it's already an hour in. So I'm gonna try to zoom past the rest. There's not, there's like 20 more slides. We're gonna zoom past, so you guys can read this as you need to. It's useful. I mean, if you read the book, it's kind of the same content. So yeah, I'm just gonna go by this a little bit quicker. Namespace refers to the mapping of a variable to a value. So like when you assign a value to a variable, um, it takes up memory in Python, and that's what they refer to as namespace. Um, concat, uh, I don't even know. I'm not gonna even try to say this word. uh, yeah, English is not my first language, so I'm not gonna even try that. So this basically means you could connect multiple strings to one another. You can also, uh, yeah, it's only for strings. So in the screenshot, you could see I created a string, and then I added another string, which is the exclamation point, and then it added both of them together. Multiple assignment. So this basically, it's kind of like a shorthand. Say you have a variable that's a, b, and c. You could do a equals 1, b equals 2, or you could just do a, comma, b, comma, c equals 1, 2, 3. That it works both ways. It's just a little bit quicker this way for programmers who are writing a lot of code who have to define a lot of different variables. It's just easier. Um, Make sure if you do this multiple assignment feature, you have to have the same number of variables as you have values, or else it's going to return a traceback error telling you not enough variables, not enough values. So yeah. Um, Naming identifiers and reserved words. So there are rules on defining identifiers that can be used for variables, classes, functions, modules. Rules for naming convention. You guys can read through this. It's just like Python. If Python doesn't like the name of a variable that you're using, it's going to tell you. Um, it's either going to return an error or, well, it usually returns an error. So if you try to name a value that's like import equals something, because import is used to bring in other external libraries, it's going to reject it. So important note. So if you define a variable like hello, or not hello, name, so like name, but everything's lowercase. That's one variable. Now if you do uppercase N for name, that's a whole different variable that has another value assigned to it. So it's sensitive. So just note that. Naming conventions. As we saw in the previous labs, we used underscore. Totally fine if you're trying to write compound names. Avoid. Yeah, you guys can just. It's just simple rules that are not mandatory but recommended to make code more readable. User input. So if you wish for a user to enter input into a program, such as assigning a value to a variable, you can use the input function. So it's not the same as the sys function that we saw earlier of argv. This is more specific to, say you're writing a program that requires the user to type in specific input. So like, I believe there's a screenshot later on. Okay, right here. So we use the input function to request the user to enter in data, but how does the user know what to enter in? So in this case, we defined a variable tongue twister. We assigned it a value of the input function, which basically means user, please enter in something here. I want the user to define the value for this variable, not myself, the programmer. So we do input, and then within the parenthesis, you can write instructions for the user. So in this case, it says enter a tongue twister. And so when we print this out, when this program runs, it's going to run, I believe it should say, yeah, so right here. I don't think you see my mouse, but underneath here it says enter a tongue twister. The user's going to write whatever they write. In this case, it was she sells seashells by the seashore. And now if we print the variable of tongue twister, it's going to print out what that user wrote. So at the very bottom we see it. So finding integers and strings. We went over, just seeing how many slides we have left. Okay, we're getting there. So we went over how to convert a string into an integer and vice versa. We could also, Python also allows us to retrieve integers, like numerical values, out of a string. So like say a user returns whatever we write from the input function as a string. Everything's returned to as a string. But say we want the number, but we don't want the entire string itself. In that case, we would use the int function, or the input function. So in this case, the example is number equals int, and then input, so int, open parenthesis, input, open parenthesis, find the square root of, colon, space, and it finds it within the string. So I don't know if we have an example of it. I guess this is it. Yeah. Okay. If you have questions on this, just let me know. Yeah. Input function, the previous code shown. Oh, I think I explained it here. I was like, I swear I explained this. The previous code shown in the command prompt image accepts user input using the input function. The user inputted the integer 49. So if we go back here, we see, so yeah, it uses the okay, I think I understand what I wrote. First, it uses the input function, which allows the user to input data into the program. Then it prefaces the input function with the int function, which takes the number of the inputted data for the programmer. So in this case, when we ran the program of the seashells, say that program wasn't for seashells. Say it was asking the user, please enter in how old you are. The user types in 20. But that value is returned as a string. So the int function allows us to pull that value out of the string. In this case, it's saying the previous example was 49. You could also prompt argument to the input function that acts as a queue. We went over that. Yeah, the input function will always return values as strings. Even though 49 is a number typed by the user, it's received by the programmer as a string, so this int function will bring it out of a string and represent it as an integer. So it's useful there. Comments, very important. I think you'll always see it in the labs. For the most part, it'll be at the very beginning. It'll say like write your code here, but like it'll have the pound sign prior to it. that kind of like it's used so that a programmer can see like any notes that the program is about, but it doesn't run with the program. It's kind of like hidden from the program in that form, if that makes sense. There's three different ways to write comments in Python: documented strings, inline comments, and block comments. So the block comment uses the pound sign prior to it. Pretty straightforward. The inline comment uses the pound sign as well, but it's usually placed in the same line as a line of code is. So like, just make sure you do it after the code, not before, or else it's going to cancel out whatever code you're writing. Because the pound sign basically cancels out everything after it, not before it. So just keep that in mind. Um, for that line, not for lines below it. So yeah. But if we wanted the our comments to affect multiple lines, that's where you're gonna write the use documented strings. So doc strings are used for multi-line comments. They use triple quotation marks. So here in the example, you see uh, three sets of triple or double quotation marks, and then you have the next line where you write the comment, and then the next line where you close the comment with the same triple double quotation marks. Um, we have block comment or no, not block comments. That's it for comments. We have blocks. Blocks are a group of statements that are meant to be executed together. So this statement's a Boolean statement because it's basically like it's interpreting code. We're gonna get into that later, not this chapter. But just know that a block comment is like a group of statements, a group of code that is executed. Um, so when you're defining variables, that's not necessarily a block comment. A block comment is more like the executable piece of code, like a print statement in a way. Something that's executed by the program. Variables are used by the program. So, yeah. The use of the if command allows for Boolean expressions to determine where the program should go. In the example shown in the previous statement. So yeah, like I said, we're going to get into Boolean statements later. They're just kind of lightly introducing Boolean statements, the if, else, yeah. Indentation. So indenting your code is pretty important. It defines where one block statement starts and where it ends, and then where a new one begins. So for the if statement here, we see if, and then the next line's indented. That whole indented area is a whole block of code that gets executed. Then we see it's outdented for the else statement. That means that that previous block of code, it's done. Now we're entering into a new block of code. That's why we outdent the else and the if. So yeah. And then indentation, I think this literally just said what I said. So yeah, that's it for the PowerPoint. We're going to go over the final lab. I believe there was one more. Close this. I believe it was 1.3b, but I'll check the syllabus just to be sure. Yep, okay. So this is the final lab. We're just gonna... Okay. Yeah, it seems simple enough. Okay, so aim. Using a Python script, run on the command line. Calculate the diameter and area of a circle with a radius of 3. In this activity, we'll get better acquainted. Okay, so it wants us to find the diameter and area of a circle. That's it. Oh, and notice right here, let me just make sure okay. Notice right here that this right here is a comment. This is I believe it was the not an inline. I think it was a block block comment. Block comments are usually preferred because they preface any code, like it's the first thing you see, so it's preferred because it usually gives the programmer a heads up on what the program's about. So that's why it says write your code here. So yeah, it wants you to find the diameter and area of a circle. So what do we need for that? We need pi, and we need a radius. It gives us the radius, which is 3. So that's great. We literally just need those two variables defined with values. So they actually give us the value of pi that they want us to use. So we're going to create a variable pi, assign it the value that it gives us, which is 3.14159. That's it. Okay, the next variable we need is the radius. They give us the radius, which is 3. So actually, we're just going to do r. Makes sense. Do 3. Okay, that's literally it. Well, it's not it, but that's that sentence. So now they give us the formula for calculating the diameter, and they give us the formula for calculating the area. Okay, so let us do diameter first. Diameter, I spelled that right? Yep. So diameter is 2 times radius. That, yeah, 2 times radius. I don't know why I deleted that. Okay. And then the formula for the area is pi. So pi gives me this here. Times radius to the second power. So to do to the power of something, you do 2 times, or two stars. And that tells Python, take this to the power of something. In this case, it'll be 2. And that should be it for that. And now we have to print this, because now that we defined the variables, we gave it the values. We then use those variables to find what the program wanted us to find, which was diameter and area. So the final thing, it should be printing this out so that the program gives us output using the stuff we wrote. So now we're going to do the print statements. So it wants us to find... So actually, if we go down here, it gives us the specific string it wants us to write. So print diameter of the circle. So don't forget the colon, space, close parenthesis. And then print area of the circle, colon, space. And we're not done yet with the print statements. Now we have to insert the final calculation that we did right here in line 5 and 6. So this is diameter, so we're just going to type in diameter. That's it. And then here, area. And now it should work. So now Python, we're on the terminal now. .py. Did I spell some? Oh. I'm pretty sure I just typoed something. Diameter. What did I just type? Oh, I'm trolling. I forgot the... Yeah. Don't forget the commas. So after you end the string, if you're going to add something at the end, you need these commas. You can't just add them. So Python 3 main.py. There we go. Okay. So yeah, and if I click these boxes, they should work. Yep, perfect. So that's the final lab that was assigned to you for homework. Every week, I'm not necessarily going to go over all the labs. I might go over one or two just to give you like some guidance on how to approach the lab as they get harder. But I just wanted to go over these labs because it's your first week. It's a whole nother language, and these labs are not super hard, but it's just kind of the way you approach these problems has to be meticulous. You have to take it sentence by sentence. You have to. They're not going to just spell it out saying like, this is the variable, this is the value. They're going to write it like kind of like a math problem, and you just kind of have to pick the data out. You have to know, oh, this must be the variable, this must be the value assigned to the variable. If you have to do calculations, they're probably going to include the conversions of certain things as they did it in these labs. But you just kind of like it's basically like you do the groundwork, then which is like the initial variable defining, and then you use those variables to do calculations to find something to find a new variable. And once you do those calculations, then you print out your output. Or else if you don't print out your output, then you just did those calculations for nothing. Because when you run that program, nothing's gonna come up. So yeah, that's week one. That's chapter one. That's the labs. I know it's a longer video. I'm gonna try to shorten them as we continue going on. I just had a lot to say. Just want to show you guys my approach to Python, and yeah, I promise I'll try to shorten the future videos by a little bit. Maybe not cover the entire PowerPoint. We'll see. But yeah, it's nice to meet all of you guys. I've been reading through some of the discussions. I'll be posting chapter 2 content uh, soon. I don't want to promise a specific day, but soonish. Definitely before week 2 starts, I'll post it. So just look out for that, and best of luck in your other courses. I look forward to having you guys in future weeks, and I hope you guys learned something. All right, it was nice talking to you guys.